What's up everybody, my name is JJ with Piazza Research, and in today's video we are going to work through some general physics concepts. In fact, we're going to take Newtonian mechanics and apply it to a scenario you wouldn't typically see, and that is to a binary black hole system. And maybe I'll throw up a little video or image of a binary black hole scenario where two black holes are in an orbit with one another around their center of mass, moving at a constant velocity or a constant speed, and then they are eventually going to merge. And we're going to kind of work through this step by step and see how we can use expressions from general physics and classical mechanics to understand this system. And so why don't I begin by sketching out kind of the scenario. And so we have a perfect circular orbit with two black holes, one here, one here. And let's say we were able to measure the mass within each of these black holes, and it came out to be approximately the same, and we're going to call that M. Maybe they ate up the same amount of stardust in a given region equally, and then that's why they have roughly, unlikely, but still possible. And then let's say we also had some sort of instrumentation to measure the diameter between these two black holes that we are going to treat like point masses, which is important. And so let's say the diameter was measured, and we're able to compute the radius given that diameter. And let's say the radius was r0. So now we have a few things to work with here to better understand the system, and maybe we were tasked with finding the velocity of a black hole, of both black holes. And so maybe I'll write that down. What is the velocity of our black holes? And so when you see a uniform circle with motion, you can think of uniform circular motion immediately, and with that always comes centripetal acceleration. And so centripetal acceleration is a change in direction. It's an acceleration you feel because of the change in direction as you go around the orbit. And let's say that this orbit is going in this clockwise. I don't like the way this arrow looks. Sorry, hold on. And so we have an expression to understand centripetal acceleration to be the velocity of our point mass squared divided by its radius, in this case r0. Cool, so now we have velocity already in our equations, at least, but we don't know centripetal acceleration. We aren't given that value. We don't have any measurements for it. So what else can we use to maybe, find velocity given the information we have and we were able to record? And I immediately think of Newton's second law has acceleration in it, and that's force equals mass times acceleration. The sum of the forces equals mass times acceleration. These are vectors, not important, but we see here we have our two A's now, but we don't know what forces are acting on our black holes. So that makes me think of gravity and Newton's law of universal gravity, big G. I think about big G, little g. I know little g is associated with locality on Earth and doesn't apply outside of Earth, but big G does. That constant is useful beyond the scope of Earth. And so why don't we write that expression out? We know that equals big G times our two masses, the distance between them, which we said is 2r0. because r naught is equal to the radius. And this is a force of gravity. So now we have an equation in Newton's second law that we can plug in values which we found elsewhere using expressions that have already been experimentally validated. And so we can, let's plug these guys in. And so the force, big G m squared, equals 2r naught. And then our m is just m. And then we have our centripetal acceleration, which is v squared over r naught. Cool. We now have our entire equation expressed in variables with which we have measurements or data for. And so we can solve for our velocity using algebra. And so we can throw this m over here. We get gm over 2r naught equals v squared over r naught. And then throw r naught over here. Oh, I made a mistake on this expression. This is actually squared. I was like, this doesn't make, something's missing. And then, because I don't want my r naughts to cancel out. And so there, now in this case, and this would be 4. Because this whole thing would be squared. And so now we take r naught over here. And we get v is equal to the square root, capital G over m, for 4r naught. This can be simplified even further. 1/4, square root of 1/4 is just 1/2, times the square root of g over m r naught. And so there we were able to find our velocity of our black holes. The next question we could ask ourselves is, what's the energy of this entire system?